Hi, in this video we are going to see about the analysis and trade-off that break-even analysis we are going to see in operation management decision taking. Okay, we are discussing about decision taking process. In that, how the break-even analysis is going to help during this maximizing and minimizing of profit, and some problems we are going to see here. So the thing is, first, break even analysis. Okay, it is an analysis, it's a graphical representation. So it is by keeping some volume in that is x-axis and y-axis, some variables we are going to keep, and we are drawing a graph. Through the graph we come to know what is the profit, and what how where the profit starts, or which is the point where there is no loss at all. So exactly we are going to, this is helpful for maximizing the profit and by minimizing the losses. So it depends upon some variables. The variables we can call it as some production cost, how much we are selling, how much volumes produced, and what is the volume of profits. All these variables will help you to draw this graph, and by drawing the graph we can come to know that what is the profit and loss or cost volume profit model we are going to create here, through which we come to know that the profit or loss areas. Okay, so here in this case, what is the first cost we come to know? It's we are spending more capital in we are investing capitals, right? So for before completing the problem, before starting the company, we need to purchase the land, right? And then we have to construct a building for keeping your machineries. Then you are purchasing machineries, then that making the machineries and arrangement, proper arrangement, you are keeping all the things before starting the production. Even a single piece is not started, the production we are whatever the cost we are involved invested in it, we call it as fixed cost. So the fixed cost, examples of cost of the land, cost of the building, and what is the taxes we are paying for the building, or taxes pay for the government. Even we are not starting any production, the amount what we are spending is called a fixed cost. But the variable cost, it depends upon the volume of production. If it is a single product, if you are producing, how much amount you are spending for producing the component, right? So for electrical power supply, how much amount we are paying for that, and how much amount you paid for the workers, right? And maintenance during the breakdowns and whatever it comes, because after started the production, during the production, so each and every volume, each and every component is getting counted. And that is what it's some variable cost. Raw material we are purchasing and we are keeping in a store. Before production, it's a amount invested on the raw material, it's a fixed cost, but maintaining that, keeping for a long, that and all, it depends upon the production. If what you have started is it of production, it's called prime cost. When production is more, when components you are producing more and more, the variable cost will be more. When there is no production, the variable cost will be zero. But in the case of fixed cost, even we start a production or if we are not, fixed cost is fixed, it's standard, right? And then we can see this graph here, that's what the total cost, variable cost and then fixed cost, it's a combination, it's a sum of the fixed cost plus variable cost. So if you see the graph, at the horizontal x-axis we put volume of output, and y-axis the cost. So fixed cost, it starts, even the volume is zero, we will have some amount what we spend on land or machineries, or and everything, the taxes and everything, that some amount, a little amount, it's a fixed one. So it's a constant. You can see whether the volume is there or not, volume of production is there or not, fixed is constant. And next, this is volume of output and cost. The variable cost will be getting increases according to the volume of production. If there is no volume of production, the variable cost is zero. If there is more volume of production, the variable cost increases accordingly. So the graph is linear, you can see. And the combination, that's the sum of the variable fixed cost and the variable cost, it will give the total cost. So that is the last, in the last slide you can see volume of output, and it starts actually the total cost starts from the fixed cost, and the line increases linearly, it goes along with the variable cost, right? So this is the total cost. And sales revenue, so what is the revenue? Revenue is the income through the sales of the project. So when we sales the product along with the profit, then that we call it as a sales revenue, right? Break even point, now we are going for drawing the break even point, finding the break even point by using the break even analysis. So the break even point is a that's a break even chart or break even analysis graph. It's a representation of the total cost and the sales revenue. So that when we are drawing the total cost line and the sales revenue line in a graph by keeping volume in the x-axis, output of volume, and cost, that is the incomes, in the y-axis. So when we keep horizontally x-axis and y-axis vertically with the variable revenue there, then we draw the graph. We will get intersection of both the revenue line and the total cost line. So when it gets intersected, the point of intersection is called break even point, where when the income and costs are equally getting balanced, there is no profit, no loss, right? So here analytical method, this is what it shows. So a margin of safety is the actual sales to the break even sales divided by the actual sales. It distance between the difference between the actual sales, okay? The point, break even point, and the actual sales, we call it as the margin of safety. So here you can see the graph, volume of output is the x-axis, and y-axis is the cost of revenue. We have drawn the variable cost line and the sales revenue line, okay? If there is a difference between the sales revenue and the variable cost, we call it as contribution. And now when there is a intersection between these 2 points, sales revenue line and the total cost line, okay, there is the point where in this graph you come to know the angle of incidence. The angle of incidence is the angle which is between the sales revenue line and the total cost line. Already we have seen what is a sales revenue, the revenue created, the income created by selling your product. So if zero product is sold, then zero, the cost is zero. If number of increases, the volume of component get increases, your sales will be it's a linear graph, it shows your revenue. And at the same time, already we said fixed cost is the cost which is certain, and the total cost is the combination of the sum of fixed cost plus variable cost. So we are drawing another line. So here we can see that so in this the fixed cost, it will start from here and it goes the total cost. So what it is graphically, and this sales revenue is inclining like this. So here when we are taking this both line intersecting, the point is getting intersected at there, and this angle in between these two is called angle of incidence, okay? Right. So now this is what the angle of revenues and total cost line is called angle of incidence. A large angle indicates the large profit, and lower angle, it indicates the profit. That is a higher the profit. So now we are going to see that. Sorry. Right. So sales revenue we have seen on the larger angle of incidence, if you see that large profit, and in the profit volume ratio, that is BEP, break even point, the formula you can see here, fixed cost divided by S minus V, sales revenue minus variable cost. So we can follow this so to get exactly what is the break even point, where it is total cost. Already we have discussed fixed cost plus variable cost. And now one problem here we can see If fixed cost of the manufacturing of certain product is 3 lakh rupees and variable cost is estimated 40 percentage of the selling price, then what is the quality of sales at the break even point? So first, from this given data, fixed cost is given as 3 lakhs rupees and selling price per unit is 100 rupees. What is the variable cost if it is a 40 percentage of the selling price? So selling price is 100, 40 percentage of selling price is 40 per unit. So that is a variable cost. So by keeping the variable cost, fixed cost and the selling, we are going to find the break even point. As well as in the formula we have seen, BEP is equal to F by S minus V. So 3 lakhs divided by the selling price and the variable cost, if you see, 5000 units. So this 5000 units is, there is no profit and loss situation. So for any problem, you can, if you have fixed cost and if you have variable cost with the selling units, then obviously you can find how many units we can produce for no profit no loss. So from this problem we come to know, if you produce 5000 units, then it is the point where there is no profit and no loss. If you produce less than 5000, then surely you will get a loss, and if you produce more than that, you will get a profit. So here in this graph also we can see that the volume of output is, if it is 5000 and the total cost, then the BEP point, here you will get the point. That is a point where there is no profit no loss. So by calculating this, by using these formulas, we can calculate the break even points. Okay, so now up to this it's okay for this video. Next we will see some other problems.